Much. Well, hello everyone. Thank you so much for joining us today, right? My name is Fernando Rocha. I'm a customer success engineer here at Diagrid. Prior to Diagrid, I worked 2 years at Microsoft and then 3, 4 years at AWS, doing basically the same role as a solution architect, helping customers navigate the products that we were building, and most importantly, how to build um, them in their architecture in a well-architected way. So I'm very happy to be here. As we mentioned, we do these webinars monthly, so make sure you subscribe to our LinkedIn newsletter. Make sure you subscribe to our YouTube channel because all of this content is going to be there eventually. So if you miss a little bit today, or if you want to take a look at what we have posted before, feel free to do so by going there. And again, this is end-to-end Dapper management in Azure, specifically with Diagrid Conductor. There's a lot for us to discuss here today, but overall, we're going to talk about, we cannot talk about Conductor without talking about Dapper, right? And we cannot talk about Dapper without talking about distributed systems and their challenges. So that's the first thing we're going to do here. We're going to talk about why we have distributed applications, what type of challenges they bring to developers and operations people. We're going to talk about a little bit how Dapper helps you overcome these challenges and how you can add Dapper or embed Dapper into your Azure applications in multiple different ways. And then we're going to take a step further, right? We're going to talk about how after you add Dapper to your Kubernetes environment to help you build your distributed applications, how you can maximize your productivity as someone for operations, DevOps, or as a developer using Diagrid Conductor. If you've never heard of Diagrid before, right? Diagrid is a company that was launched back in 2022 by the co-founders of Dapper project, actually, Mark Fussell and Yaron Schneider. And their idea was to take Dapper, which they're really proud of, and make it more accessible to a broader audience to use. So if you met me before, you know that I really love APIs. You know that I really love distributed systems. I've been trying to work with those topics throughout my career for a long time now. That's why Diagrid's mission is so cool to me, right? So our mission today is to boost developer productivity by providing tools and APIs for building and operating cloud native applications. So Yaron and Mark, they really understood that cloud native applications are the thing, right? They understood that they have a lot of challenges. That's why they created Dapper, and that's why they created Diagrid after that, to make sure that we all have access to a tool that helps us build these distributed applications in an easier way. And if you think about 10, 15 years ago, maybe 20 years ago, it was hard to find people who had roles that were different from developer, server administrator, or DBA, right? That was basically what we had. You had your IT manager who was managing everybody, but that's all we had, right? Things are a little different today. You have DevOps engineers, you have SREs, you have a lot of different developer engineers, different types of engineers for different types of products, front end, back end. Things have become a little bit more complex, right? You have cloud engineers, system engineers. And that's because we have moved away a little bit more from that monolithic way of building applications, as everything was sitting in one single server. Maybe you were a little bit better architected and your database was in a different server, right? And you had someone to manage that. But today in this cloud native world, right, development concerns are growing a lot, right? Especially with the requirements around multi-cloud, you have a lot of polyglottism, and distributed applications are becoming really popular because with distributed applications, you get flexibility, you get speed, and you get honestly a much better way to do what you can do, because instead of having one big blob of code to manage in one single programming language, you can pick different parts of your application and build using the best framework, language, communication method, communication library, data stores, clients that you can find for that particular topic. And it's easy to mix and match, to test and make sure that you're using the best thing possible for you. But that brings us a few problems, right? Let's talk about the demo that we're going to cover today. It's gonna follow us throughout this particular presentation. But let's think about an order system, right? You have different components associated with it. You have, of course, someone placing an order to an order service, the order service mainly being responsible for receiving orders and sending them to a queue. That queue can be anything you want, any type of message broker that you want. Let's think that an order processor is going to pick that order from a queue and it's going to orchestrate a process between a make line service, who is responsible for managing the state of the order, a receipt generation service, who is of course responsible for generating the receipt after the order is completed, and the loyalty service that's responsible for managing the loyalty points for the customer, right? This is all backed up by state stores. You can think about any type of state store you want, but mainly you just want a place to store the data that you're creating or manipulating there. And you have a virtual worker, who is a scheduled task, who is responsible for closing these orders at a particular cadence. Again, this is all backed up as a message broker. So once an order is finished, it goes back to the message broker as an order completed. And that's what we have today. Okay. So what are the challenges that we see here? So first of all, when you have distributed applications, you need to orchestrate all of this process. But mainly, let's focus on the order processor, right? So you have make line service, you have receipt generation service, you have loyalty service. You need to make sure that all of them are working together or none of them are working, right? So when you think about patterns that are related to orchestration and choreography of applications like the Saga pattern, Outbox pattern to an extent, right? You need to maintain some type of logic between those service calls. How do they work? If something fails, how can I roll back? If something happens in between, should I need an approval to move forward? Should I need someone to go and interfere before I make sure that everything's working perfectly again? Right. So that becomes a little bit complicated when you have applications that are distributed around and need to make sure that they work. How can you trace requests across services and message brokers? How can I make sure that I'm sending the right data, right? How can I make sure that everything is working as expected? When I send an order from my order processor to start a workflow on the make line service, how can I make sure that things are working properly? How can I make sure that I'm sending the correct data? How can I make sure that I have the proper error rates being collected? And how can I configure access to services and other resources? Again, we're not talking about a monolith anymore, where all of your modules and components have access to everything, right? We're talking about distributed systems. So why should order service have access to make line service? Why should order service have access to the state store that loyalty service is using? It doesn't make sense to do that, right? It doesn't make sense to have that. So you need to control that particular access to allow or disallow access, most importantly. And how do you handle failed calls and perform retries? If something fails, do I want to try it again? How often do I want to try it again? After which period of time I want to try it again, right? So you need to configure that per service. You need to configure that, making sure that everything is working properly and following whatever rules you have created for this to follow. So because of all of these issues, Dapr was created, right? Dapr stands for Distributed Application Runtime. And what it basically is, it is a unified programming model that exposes application level APIs that help you build distributed applications, but with best practice software and patterns and practices involved, right? Based on all of those challenges that we have seen before. And my favorite part about Dapr, with complete code portability across cloud and edge. And we're going to talk about that a little bit more in a few slides, but that's my favorite part about Dapr. And how does it work? If you want to take Dapr as a developer and you want to go all the way to production, there are a couple of things that you need to understand. The first one is when you're building your application, your business logic, you can use any type of programming language you want. Node, Python, .NET, Go, Java, it doesn't really matter. Okay, you can build your Dapr app in any type of, you can build your app in any type of programming language that you want, using any type of framework that you want. The app itself is going to talk via HTTP or gRPC to a sidecar, a Dapr sidecar. Again, we're going to talk about that a little bit in a few more slides, but that sidecar is responsible for translating that request that is coming from the app, understanding what type of invocation that the app is making, right? Even starting a workflow, publishing something on a message broker, invoking another service from another app, managing state, actors, binding secrets, it doesn't really matter, right? But the thing is, it abstracts that request from the app itself and performs that invocation to whatever infrastructure you have running on your infrastructure, right? But important thing is with that adding the observability, security, and resiliency, all of those best practices that we talked about before, they're automatically embedded. And overall, you can host that in any cloud or edge infrastructure, right? You can host it on Azure, AWS, Google, Alibaba, Kubernetes itself, any type of distribution you want, or even physical or virtual machines if you want to do so, right? But the reality is, by working with a lot of customers and by running a lot of surveys, we have realized that over 90% of our Dapper workloads, right, of our customers or people who are using Dapper, right, they are using Dapper on Kubernetes, 90%. So that's why we're going to focus a little bit more on Dapper on AKS today. Now, I talked about the sidecar panel a little bit more. I talked about how Dapper, the sidecar, is responsible for abstracting that request. Again, right, if you're not familiar with the sidecar pattern, what it is provide a container or an app, right, a separate container or process that is responsible for platform abstractions, as I mentioned to you before, communication to remote services, logging, configuration, all of those things. So basically, you never have service-to-service communication. The service talks to the sidecar, and the sidecar communicate with each other, okay? That is great because it provides full isolation from your application, right? Your application is never talking directly to another application. So the sidecar is responsible for managing all of that communication. And that communication between the application code and the Dapper sidecar is always through localhost. So regardless if you are running locally on Kubernetes, or locally or on Kubernetes, sorry, there's no code changes when you change environments. So the way that the app communicates to the Dapper sidecar is if I want to invoke a method on another app, instead of calling that app directly and calling a REST API or whatever API that is exposed, I'm going to call the Dapper API invoke, passing whatever information that is needed to call that app. If I want to manage state, instead of going straight to Redis, Azure Storage, Azure, or any other type of Cosmos DB, Azure SQL, I am going to call the state API, and I'm going to pass the name of my state store, and I'm going to say, I want to add, I want to get, I want to delete, right? Only using HTTP verbs, right? So it makes it much easier for your app to work with this backend infrastructure because it makes it really streamlined. So it doesn't really matter what type of infrastructure you have, right? Those are only the Dapper components on Azure, right? If you go to other cloud providers, yeah, there's much more. Today we have over 120 components available. They are all open source and they're contributed by the community, of course, and they're written in Go. So if you don't see something here, for example, when I worked at Microsoft, I was a big fan of Azure Maps, right? I worked with geospatial technologies before I joined Microsoft. So I'm very fond of this type of technology. So let's say I love Azure Map. I realize there's no binding for Azure Maps on Dapper, so I can just go and propose that, or I can build it myself, and it's going to go through a committee, and they're going to say yes or no, right? But the possibility is there for you to do whatever you want. And for state management, publish, subscribe, binding, secret sectors, external configuration, distributed lock, workflows, and cryptography, you have a lot of different types of components that you can use here. Okay, so you're not constrained to one or two. You have a lot of different options for you to choose from. Okay, and that brings that flexibility that I talked to you about. If tomorrow you change into a new cloud provider, if today you are on premises or running everything on Kubernetes, you're running Kafka and Redis on Kubernetes, but you're moving to a multi-cloud environment tomorrow, right? The great thing about this is you wouldn't need to change anything on your code itself, right? The only thing that we need to change is a YAML file associated to the infrastructure that you, and we're going to cover that in a few slides as well. So that's our other system today, right? Without Dapper. our order system without Dapper would need a couple of things here to work properly. So mainly you would need an SDK client to everyone that interacts with some type of infrastructure. Order service, make line service, and order processor would need an SDK client to interact with this queue. It could be Kafka, it could be Redis, it could be Service Bus, whatever you want it to be. And loyalty service, receipt generation service, and make line service would need some type of client SDK here to interact with this key value store, the state management store. All right, so your development team is going to need to learn how this client SDKs work. And if something changes, you need to change all of the services here that are interacting with the infrastructure below. Okay, so there's a lot of development work there. There are a lot of things to learn. There are a lot of things to understand, best practices that are associated to every single one of these infrastructure pieces. In an order system with Dapper, it would work a little bit different, right? So instead of having all of those client SDKs embedded in every single one of the SEPs applications, the only thing that you would need to have is a Dapper sidecar who would communicate with this backend infrastructure here, Kafka and Redis in this particular use case. And again, just using the Dapper APIs like I showed you before, right? You want to use the publish here API to publish something on Kafka. You would use the state API here to manage state inside Redis. So that makes it much more easier the way that it works. So if I had this type of architecture here running on Kubernetes using Kafka, Redis, whatever I'm using here as an infrastructure, and my CTO says, hey, we're moving tomorrow to Azure, right? So you need to change every single piece of infrastructure that you have here because we're moving there. We want to use managed services. How do you do that? So the way that you would do that, you would, of course, deploy all of this new infrastructure, right? Using Azure Components, Service Bus, Table Storage, Cosmos DB, whatever we want to use, right? I'm mixing it up a little bit here, and there are more options that you could pick from. But once those apps are Dapper enabled, all you would need to do is start using the APIs that are already there, right? You already developed your code. You already have those apps working, interacting with a backend infrastructure by using the Dapper APIs. So basically, you wouldn't need to do anything here from an application perspective. All you would need to do is change a YAML file that is associated with your infrastructure. And you could be able to use all of these APIs that we see here, like publish, subscribe to talk to Azure Service Bus, workflow to manage the workflow between these three services here, state management to manage the state on Azure Table Storage and Azure Cosmos DB. You wouldn't even need, right, to understand how Azure Cosmos DB gets, you can get data, you can store data, you can delete data. Same thing with table storage or other types of tools that you want to use, right, for state storage. They will all work exactly the same way. So you can flip this, make this however you want. It doesn't really work. And the reason why this is like this now, your developers, or if you are a developer, you can focus on what's really important. You can focus on make line service, closing an order, but focusing mainly on your business logic instead of focusing how your Azure Cosmos DB is going to handle that data. If you change it to table storage tomorrow or Redis again, how that would work. You don't care about that anymore, right? You care about your business logic within your app. And how these components are going to be added to your application, right? So all of these components are going to be added to your application by using YAML files. That's the state of a YAML file here that adds, I believe this is Cosmos DB to it, right? So if you worked with the Kubernetes before, you worked with YAML files before, that's very familiar. But if you go and see our list of our components online, the documentation, you see that they all follow the same pattern. The only thing that changes is the type of metadata that you send to it, right? And of course, the type of it, but they're all components. They all have their type of configuration that you need to do, and they all have a scope that you can define, right? It doesn't matter which component is there. If you go to our documentation, or if you use Conductor, there's a very easy way for you to manage those YAML files as well. Well, create those YAML files as well. And how does authentication work? So The great thing about this is most Azure components for Dapper for Dapper are currently supporting Microsoft Entra ID, right? And that's great because you can use managed identities and you can use role-based access control to really fine-tune the type of access that your application is going to have to that backend infrastructure. But if you're using shared access keys, you can also use that. There's also a way to use that, connection strings, for example, and they can be used and stored as Kubernetes secrets or in Azure Key Vault if you want to use them, right? And then just embed them into your YAML file and use them as well. You can even use them as clear text, but put them there as clear text, but we don't recommend that because that's not a best practice. And always, of course, try to use managed identities when you are building something and authenticating against this infrastructure pieces. From an integration perspective, right, Dapper can be enabled in multiple Azure services, either through configurations or extensions, right? There are just a release that came out on build, facilitating the way, oh, I have Azure Service Bus here that shouldn't be here. Facilitating the way that you can add Dapper to your Azure Container app. So I recommend taking a look at that. But there is a way to access Dapperized apps via Azure API management by using configurations. There are extensions for Azure Functions and also for Azure Kubernetes services. So if you want to use Dapper on your applications there are a couple of ways you can do it. You can install things on your cluster. You can install Dapper on your cluster manually if you choose to do so. But if you want to make use of the extension to make things easier for you, you can also do that. And that's a little bit of how our application would look like if you were on Azure, right? You have everything on Azure here, but now Kubernetes is only responsible for handling the application itself. And we have all of these managed services here handling it. I have a better slide to cover that. Big question that we get from people usually is, how can we trust Dapper if it's an open source product, right? How can my enterprise, how can my organization trust Dapper if it's an open source software, right? Can it end at any time? Yeah, everything can end, right? If it's open source or not. But the numbers here don't lie. The numbers tell a story that, and the story is Dapper is pretty popular, right? Dapper is the 12th largest project in the CNCF, Cloud Native Computing Foundation. Okay, it has over 3,000 contributors today. The community is very vibrant, as you can see here, right? 7,000 Discord members, unique views, over 300K unique docs views per month, over 1 million plus, over 1 million Doc Hub posts per month, right? On the Dapper containers. We have 120 community components today and more coming, and 22.3 thousand GitHub stars. So the community is really there. But if you want something a little bit more I don't know, solid to understand how popular Dapper is, you have a lot of contributing organizations that are not only maintaining Dapper, helping us maintain Dapper, helping us make sure that Dapper is solid, right? But also using, have Diagrid, Amazon, Microsoft, VMware, Alibaba, HashiCorp, Intel, SAP, so all of those. So if you're thinking about, should I trust Dapper, right? So if this organizations trust Dapper, if these organizations are using Dapper, I'm pretty sure you could do without any issues. And again, that's our order system as it looks like on Azure Kubernetes Services today, right? With my infrastructure, I can show you that really quickly, if you don't mind. So I have here on Azure, I've created this resource group here, and I have all of my components. I have Azure Kubernetes, I have Azure Redis, Azure Cache for Redis. I have a Cosmos DB account, a Service Bus namespace, and a storage account here that I'm using. Okay. Now, if I go to my cluster here itself, I see that I have a couple of pods here. One of them is having a little bit of an issue, but all of the pods, all of the applications that I shared with you before are here. If this is, try to make this a little bit bigger, you can see it better. Okay. And I already have Dapper installed here on Dapper system. So Dapper is already installed here and running properly for me. Okay. I also have Redis and Kafka running locally. If I want to do that change, right? If I want to change to another infrastructure piece, I could do that without any issues. Okay. And if you never used Dapr before, you will realize here that for every single application that I have created and I have Dapr enabled, it also creates a Dapr service, right? With the cluster IP and everything associated with it. So that's how Dapr works, and that's how it would look like on your particular Kubernetes cluster. Now, let me get back into what's really. Okay. Now, by working with hundreds of customers, we have realized a couple of things, right? That Kubernetes is an amazing tool, but Kubernetes is a complex tool. And when you add Dapr on it, right, you add a tool that has a couple of containers there that need to be associated with your app. So it adds a little bit of complexity there as well. So there are a few issues, or not a few issues, but a few challenges that we have seen customers face in these years. But keeping up with latest versions and security patches, Dapr has a very solid release cadence. I believe it's 4 times a year, if I'm not mistaken. But we do release patches sometimes in a weekly basis if something happens, security issues or bug fixes. So keeping up with latest versions could be an issue. Performing regular certificate updates without incurring downtime. Dapr has a certificate that is there for you, right, to do MTLS communication. So that needs to be rotated at least once a year. So tracking and applying production best practices, you're going to see that by using the YAML files, by configuring CPU and memory properly. There are a lot of best practices that you can follow there and you need to follow, but if you're not looking at the documentation at all times to make sure that everything's working fine, it could be a little complicated and daunting for you to get to a good place. Again, understanding resource usage and controlling costs, diagnosing application memory errors and latency issues, making sense of over 150 Dapr metrics, rolling out applications to update Dapr versions every time Dapr is updated, right? Rolling out applications and make sure that you roll out sometimes one at a time or only the ones that you want to update to test them and roll back if needed. That's a challenge. And monitoring and managing multiple clusters with Dapr, it's also complicated. And that's why Diagrid has built Conductor, right? Because you develop your applications, your cloud native applications on Dapr now. You run your applications on Kubernetes now, right? And now you have Conductor to operate this cloud native applications within your Dapr environment that is within Kubernetes. And what does Conductor bring to you? So Conductor comes in two different flavors, if you want to talk about it, if you want to say it like this. Free and enterprise, right? The free versions more aimed towards developers who are testing applications and want to find issues very quickly regarding their applications, infrastructure communication, or issues that can be in their code. They can use the free version. But if you are enterprise, if you have multiple clusters, if you have a production environment that needs a little bit more care, your uptime needs to be a production level uptime, right? We also have the enterprise version with more features. And we have seen that from an operational excellence standpoint, that Conductor is able to save several days or months of days, right, managing Dapr on Kubernetes for you. So you're going to have more time to deal with other things. It reduces CPU and memory usage between 50 and 80%. It saves up to 15 days a year using best practice advisor across security, performance, reliability, and observability. We're going to see that pretty quick soon. It reduces annual downtime, but up to 15 hours a year. It helps you automate and do frequent certificate rotations if you need to do that, so you don't have any downtime or no unexpected downtime while you do it. It helps you isolate your applications and infrastructure and have all of the Dapr issues that are patched within 72 hours of reporting, right? And every time a new Dapr version comes out, it comes out really quick. on Conductor as well. I've seen like as low as a few hours, sometimes 24 hours, right? But the new version is going to be there for you. And with the new version, always comes like new advisories or new best practices for you to follow that are there for you. From an insights and collaboration, you get real-time analysis and alerting on over 150 metrics. You shrink the average app issue discovery time from 1.5 hours to 30 minutes. I have a demo to show you how fun it is at some extent to find issues on your application using Conductor, right? And how you can discover them with different personas. If you are an ops person, if you are a developer, how that would work separately. And it saves up to 10 hours a month with Apple Visualizer shared across between development and ops, right? You're going to see all of that, right? The Apple Visualizer is one of my favorite features. So let's onboard my cluster, right? Let's say I have that cluster there that I shared with you, and I want to onboard that into Conductor. So let's connect my first cluster here, or let me go back here just to show you. So when you have Conductor here, this is the enterprise version. I have more than one cluster. You can have a big list of clusters here. They are either production or non-production, right? You see the Dapper version, the number of applications around them. If you have problems with your control plane or not, if your agent's online or not, and some insights that you can have. Connecting a cluster is pretty easy. You come here, connect the cluster, you give your cluster a name, I'm going to call it Azure Demo. You pick a Kubernetes distribution, right? And you can pick any type of EKS, AKS, GKE, Red Hat OpenShift. You can also pick up Minikube kind if you want to. It also runs on those Kubernetes distributions if you want to run something on your own environment. In this particular case, we're going to do AKS. I can pick if my cluster type is production or non-production. And I told you that AKS has an extension for Dapper, and you can install Dapper on your Kubernetes cluster using that. But the best way to install and manage Dapper is letting Conductor do that for you. Okay, so you can install Dapper here and manage Dapper using Conductor. If it's already installed, Dapper is going to manage that installation. Okay, you can automatically sync the Dapper configuration. You can make sure that you have the same environment for dev and production, right? It makes it very easy to replicate that environment with the same configuration because, hey, you're using the best practices that we have embedded here for you. Pick the Dapper version here, pick the Dapper namespace. Our default is Dapper system. And you can choose to roll out all of your applications or just some of the applications that you have, right? You can choose the Helm arguments profile here if you want to. If you have a development environment, it's not going to have HA available, right? High availability enabled by default for you. But if you pick production, you're going to get not only that, but a few better recommendations for how to manage resources in between CPU, memory, and limits and things like that. So it really depends. What are you doing, development or production? You pick your own use case here. You can choose to do automatic certificate rotation here as well and set up a cadence, right? Set up a frequency for it. Every time you want to rotate that certificate and be free of it, you can set it for like a time where your application is not being used very often, or sometime where you can tell your customers that, hey, you may see some degradation here for a few minutes, but it does that automatically for you. So you never be surprised by, hey, my certificate expired and I need to do this very quickly because I have been offline for a long time. And you can do some agent configuration here. We have some configuration here regarding limits on metrics, CPU, memory, and you can choose to automatically upgrade that or not. I say yes, do it. Okay, so I'm creating that connection. What it's going to give me, it's basically a configuration that I can apply to my cluster, to my cluster, right? I can copy this information here, and let me clear this. And I can basically paste this information here, and all of the information is going to be created. My cluster is going to be connected, right? And that is a fairly quick process for the connection to complete, right? I already have a few insights coming up here very quickly. It is managing Dapper for me right now. I know that my Dapper control the Dapper is running properly, my agent's online, my control plane is online. So I'm okay with that, right? Let's give it a little bit more time for it to start picking up my applications, advisories, and everything before we move forward. Coming back to the presentation here a little bit, I want to talk to you about how Conductor actually works, right? So as I mentioned before, the first thing that you need to start monitoring your cluster on Conductor is to create a cluster connection, right? We did that already. That connection, again, is going to specify your Dapper configuration and your agent configuration, certificate rotation, all of that. So after you create the connection, again, simply kubectl apply command, the Conductor agent and the logs daemon set is going to be deployed. And this is still responsible for collecting information from your cluster, from your applications, from Dapper to show in the Conductor dashboard. Okay, and send that information to our environment. Our environment today is SOC 2 Type 1 compliant. Our engineering team is working right now in making it Type 2 compliant as well. Okay, so we're going to see that by later this year. And Dapper, since Dapper deploys several containers on the Kubernetes cluster, right? The Dapper operator, placement, injector, Sentry, to make sure that your environment is managed correctly and your apps have the correct connections to Dapper, to their sidecars, that MTLS is there. All of these containers have different reasons for being here, and we need to make sure that they're always functional. So that's what Conductor also helps with. Okay, now let's get back to our environment here. We have about 20 minutes. I have a lot to show you. So coming back to our environment here, I have a little bit of degradation that should go away in a few seconds. Yeah, it's away now. So I have a couple of things here that I can show you, right? The first thing that I want to show you is the cluster insights. You have the health of your environment specified here, your Dapper control plane uptime. You have your Dapper version, your agent version. You have, if you have any critical metrics issues, are going to show here. If you have high impact advisories, they're also going to be shown here for your cluster itself, right? From an app perspective, you also have metrics, you have error logs associated here as well. So if you find something, your app is generating some type of logs that are problematic for you, or you want to see them right away, you have any errors, they're going to show here for you. You can take a look at them. If you have critical metrics issues, they're going to pop up here eventually in a few minutes. And high impact advisory is the same way. You also have the components insight that's also going to be populated in a few minutes. Here is going to show errors associated to your components being Azure Service Bus, Redis, Azure Table Storage, all of those infrastructure components that we are using. So if they have errors, if they fail to initialize, and if you have high impact advisory issues here that are going to pop up, you see them right away on your summary. Okay. There are also a couple of easy things that you can do here. You can update Dapper if you choose to do so. You can pick the Dapper version that you want, right? Choose to roll out only one application or selected applications if you want to, okay? So you can test if they're working with the Dapper version that you are picking. And you can easily roll back if you want to as well. Okay, going over the advisories very quickly. Let me sync the advisories here. I'm going to come back to it. Let's go over the applications first. Going over the applications tab, what we have here is a list of the applications we have, right, with the name of the applications that we have created. If we have any insights associated with it, if it has issues or not. The current status of my pod, I have one here that is not running, right? I can see it right away. The namespace of my application, how many replicas I have, the total CPU and memory that's been used, and the current Dapper version that I have. From this particular place, I can roll out one application, or I can select multiple applications here and roll out if I want to as well. Okay. We have some advisories here to show you already, so let's go through this. So the advisories tab, it's here to show you if you're following or not following best practices that we have around Dapper, right? That the community has created, that we understand that are the best ways to manage Dapper on your environment. So we added that to 4 different pillars: security, reliability, performance, and observability. You can have this categorized in 3 different impacts, right? Not categorized, but added, included into three different impact categories: high, medium, and low. You can see very quickly here the types of problems that you have. So my Dapper control plane is not deployed with a high available configuration, right? That's a critical thing for reliability, right? Is making my environment less reliable. And there are a couple of things that I can do here, right? Some of this advisories, they are auto fixable. So I can fix advisory here, and it's going to deploy Dapper in a high availability configuration, right? I don't want to do that. It's just a demo, so I can choose to dismiss this advisory if it's bothering me, right? And I don't want to see it all the time because that's a development environment, demo environment, so I don't care about high availability at this point. So I can close it down. For example, it's going to shut down in a few seconds. So this place is really important for you if you want to follow best practice, if you want to understand how to mitigate some problems that you're having or don't even know that you're having, right? And that makes it much easier, so you don't have to go to your documentation, read hundreds of pages to understand what is. We have also the components tab here. That's one of my favorite tabs. I love the components tab, where it's going to show all of the infrastructure that you have configured through YAML files, right? Have the name, if it's initialized or not, the namespace associated with it, the type of component you have. I have Redis, I have Service Bus, I have a lot of Redis states here. I have a Cron's Byte, and I have Cosmos DB. The scoped apps, right? The apps where these components are scoped to. Remember when we talked about applications accessing components that they're not supposed to access or having access to them? You can do that through scopes as well. And you can take a look at the raw YAML file associated to your component, right? So in this particular one, I'm talking about Service Bus. I have a connection string here that has a value. And I'm pretty sure if I come here to my advisor, I should have an advisory here for this, saying that my component metadata contains sensitive information as plain text. Okay, so it's going to tell me what the problem is, what the problem currently is, right? I have one of my YAML files has a connection string or a password that is in clear text. I should not do that. I should use Kubernetes secrets. I should use any type of secrets. I should use Azure secret key store if I want to make this a little bit safer. You have a link to the documentation explaining what is wrong, and you have all the resources that are impacted with this. So I have 2 resources that have this problem: my PubSub, which is the one that I showed you before, and I believe my state store also has that particular issue, right? So I can fix those, update my YAML file, apply it, and these are going to be gone. So that's a good visualization piece here from the advisory session to the component session, so you can find a couple of different errors here if you want to. Okay, so that helps you automate your Kubernetes configuration to make sure that whatever you're doing here, you're also doing on your other environments. You want to make sure that these things are working properly. You want to make sure that MTLS is configured, token authentication is configured, your components are configured correctly, right? You want to make sure that you can see all of your components error here or not, okay? And there are other things that you can see. All of your configuration files are also here. You can see the raw information. Subscriptions, either if they are programmatic or declarative. And again, a lot of these terms here are related to Dapper and Dapper development. So if you want to learn more about Dapper, you can either go to our documentation or go to our YouTube channel. We have a lot of videos here that are contemplating Dapper's sometimes of a particular API, a particular module, a particular building block. So take a look at that to learn more about Dapper if you don't know about it yet, right? I'm assuming a lot of you know about it already if you are in this presentation. But if you want to learn and know more about the true value of Dapper and how to use it properly, we have a lot of cool documents. We also can see the resiliency policies here. And if you're using actors, very popular on Dapper, you can also see information about your actors here, right? If they're having issues. In my case, I'm having a lot of issues with actors. I see the invocation rate here, how many actor instances I have for a particular actor type. So you see a lot of information about all of the Dapr components and building blocks that you can have. Okay, now we have 10 minutes left. Let me show you how to identify an error here using Dapr that you may have on your infrastructure or your code. One of the many ways you could have find this error within Dapr, right? So as an app developer, one of the best features that I see on Dapr is the app graph visualization, right? And the reason for that is, as a developer, I know how my architecture should look like. I know how these components should communicate with each other. I know that by looking at this, this is not great. And I'm not talking about this demo rectal client that is failing here. That's also something that I need to look at. But I'm talking about my order processor workflow. So if we go back to our presentation very quickly, let me go back a couple of slides here. If I go back to my presentation, you will remember that my orchestration here from my order processor, my workflow requires 3 different API calls for make line service, receipt generation service, and loyalty service. Right? But I have a problem here. I'm seeing right now as a developer that I don't have a receipt generation service here. I have receipt generation service here being called by virtual customer. Maybe it has an API that it has exposed. That is great. I can take a look at it. But that's the great thing about the apps graph, right? It gives you a lot of information about your applications and how they are interacting with other applications or components. So what I can do here, I can pick up my order processor workflow and I can isolate it. And I can see a couple of things here. First of all, I can see that it's getting information from my pub sub, which is an Azure service bus, right, from a particular topic. I can see the error rate, the amount of requests per seconds that I'm getting, and the latency, all right, that I'm getting. So I can see here if this is weird, if it's not, adjust a couple of things here and there, maybe change the tier for my Azure service bus. It doesn't really matter. But what I can see here, this is currently working. And I can see that my processor workflow, it's failing 100% of the time, right? And it's failing 100% of the time because the workflow itself is failing. It's not completing up to the end. It doesn't mean that the loyalty service call is failing at this point, right? Mainly because I can see here, loyalty service is communicating back to its state store, which is on Redis at this point, right? And that is a Redis cache within Azure. So I can see that this is working properly, but I see that the make line service is not working properly because based on my architecture that I saw there, I know that I should have a state store here and I don't have it, right? And if I see here, I have an error rate of 100%. So what I can do, I can go and fetch more information from my order processor workflow. And I can see I have insights here that are showing that I have high advisory issues related to it, critical metric issues associated with it. So I can come here and try to understand if I have a little bit more clue on what is happening. So I know that I have app component error rate has been more than 30% for more than 2 minutes. App to Dapr HTTP error rate has been more than 30% for more than 2 minutes. Okay, that's pretty good information for me. But let me see if I can get a little bit more from my app. So I can see resource management, CPU, memory, everything seems to be working okay. I'm using a lot less than I should actually. Maybe it's a good understanding that I should maybe downgrade this environment a little bit if I want to. I can see the usage, the API, the CPU usage and memory usage for not only the app itself, but for the sidecar. And I can see the throughputs here, right? My HTTP latency for every single API that I'm calling. I can see gRPC I'm not using at this point, so it doesn't matter. The number of requests per seconds that I'm getting for every single one of the APIs that I'm calling. But most importantly, I can see the error rates, right? And I see that I have 100% error rates when I'm pushing data to my Makeline app. As you can see here, post, invoke, Makeline service, method, Makeline. So I have a Makeline method that I'm exposing, right? And I have the API, the Dapr API invoke being used to invoke that method, and that's failing 100%. So that's a good understanding, right? Based on that, I know that Makeline is failing. So I can isolate Makeline if I want to and get a little bit more information there. CPU, memory, pretty low, mainly because it's not working properly, right? CPU usage, memory usage, all of here, just like we saw it in the other app, the workflow app. And now I can start seeing the problems here, right? I have my gRPC latency for get state is pretty, is going pretty steadily here, right? And get state is how I am calling that state store, in this case, Redis, right? So it's a gRPC call. I have a model request per second here. That looks okay. It's not showing me anything that's really important. But if I go to the error rate, I can see that I have two big errors here. So order Seattle is my get request to my state store is not working, and post to make line is not working as well. So I've confirmed that that's an issue, and I have 100% error on get state. So by looking at this, I can understand that I maybe have a problem with my infrastructure. So instead of looking at the logs, Kubernetes logs, that could also confirm that, I can come here and look at the components that I have. And I know that I have a communication with only the pub sub component at this point. And I know that this is wrong. I should have a communication with Redis as well. So I can go to my components here and basically understand that my state make line, even though it's initialized, it doesn't have a scope tab associated with it. If I go and view the raw, I can see that everything's looking fine, but the scope is set to a different app. So as a developer, I can understand, all right, so this is not being communicated properly because it's not really working, right? So I can come here on my code, basically fix this. So I can have the correct scope. Apply that configuration. And in a few minutes, I should see everything getting back to normal. Okay. Couple more features that I wanted to share with you here before we move forward and close this. I'm going to roll out all of my selected applications here. But we just released a couple new features. The first one is the component configurator, which you can pick to configure any type of components you have, and it's going to give you a YAML file at the end with that you can just add to your project and apply. We also have an advisory report here that is new, which is basically going to pick up all of the advisories from your cluster and send to your email. So you can keep a document associated to your cluster history point at that time, right? You can add that to your DevOps documents or anything like that if you choose to do so. That's really important. A lot of our customers were asking for it as well. Okay. So there are a lot of features here. There are a lot more to show, but our time is limited here, unfortunately. Okay. Another cool thing that you can do, and I don't want to leave without telling you this, is if you're using the Diagrid CLI, you can also do a lot of interesting things, right? One of them is list your clusters, pick up the information related to it, the ID, and list advisories. List all of the advisories. Oh, not this one. Output, sorry. Yeah, you can share all of these advisories as well. You can get them in your CLI. So you can basically pick up all of that information that you have on your advisories, add that to your DevOps process, your CI/CD process. And when you deploy an application within a cluster, if you have any type of advisories, you can halt the deployment or you can ask someone to manually approve, right? Last but not least, us from Diagrid, we provide Dapr enterprise support. So if you're using Dapr in your environment, you can use us to make sure that that's running correctly. We have SLA response times that go they're up to 1 hour, right, or 24/7. We prioritize upstream features and issues for future releases for customers who have enterprise support. So we're able to deploy Dapr specifically for you if you have an issue that pertains only to you. And that's handled by the customer success team, right? Which is me and someone else. So we're going to be happy to help you with that. We do upskilling on Dapr, training on specific topics. We do architecture reviews, best practice sessions as well. You can get that also, the Diagrid Conductor Enterprise and Enterprise Dapr support through the Azure Marketplace, or if you're already using it, you can go there and manage. Make sure to sign up for Conductor, not only Conductor free, but any type of Conductor that you want. You can go to diagrid.io/conductor to sign up if you want to. We have a quick start that was just released. If you want to test Conductor, see what it's all about, start a free trial, deploy a quick Kubernetes cluster there with the Dapperized app and see the type of issues that you can find. That's a great way to start. Just go to diagrid.ws Conductor quick start and get that going, or scan the QR code on the right side there. We also have Learn Dapper for Dapper documentation. We have our newsletter. Please subscribe. Have a lot of cool content there. Enjoy the Diagrid community on Discord. We're growing. And that's all I had for you.